So here's the quiz question. So we have 1, 2, 3, on the laptop here. 1, 2, 3, 4, all the way to 12. 5, 6, 7, 8, 9, 10, 11, 12. And then A is here, C and D are here. B is between 3 and 4. Getting nothing up there, huh? That again here. B is there. B is between 5 and 6. 6 and 7 is A and C. D is between 7 and 8. B is between 8 and 9. C is between 9 and 10. A is between 10 and 11. And D is between 11 and 12. All right, there we go. So there's what they had on the quiz question. Let's do the method of markers. All right, what I would encourage you to do, sometimes in the past, and it seems like you guys did fine, but the past students have told me it's hard for them when the numbers aren't there. So if that's the case, go ahead and put the numbers in. That can help you. So here's A1, A2, A3. Just start on the left, 1, 2, 3. Just start on the left. So there's A1, A2, A3. Just do one letter at a time, A1, 2, 3, B1, 2, 3, C's first marker, second marker, third marker, D's first marker, second marker, third marker. So if that helps, just put your own numbers in there real quick. All right, because this is the way it'll look, where, this is the way it will look on the actual exam. So that's part of why I want to show you quizzes as well, so you're not surprised by the exam. I do everything I can to not surprise you with the exam. So that's exactly what it'll look like. That's the publish. I get these off the publisher's web page, pre-made questions. So there it is. Anyway, how do we do it? Remember the method? First number one marker. Always starting on the left, huh? First number one marker. That's right here, A1. So this section, that candy or whatever this stuff is, that item goes to A. And then take the first number 2 marker, right? First number 2. Now, A's out of the game, though, because A's already got their item. So let's go to, what's the first number 2 marker?
C.
Isn't it B? B2 is the first one on the left there? All right, good. So now what section does B get? Only those 2, huh? Remember, you only go between 2 of B's marks. You don't go into anybody else's territory, right? B has marked off 4 and 5 as a section for them. So that's what we get. That goes to B. Okay? Now B's out of the game. So get rid of B. B's got their section. Now take the first number 3 marker. So what's the first number 3 marker among those who are left? Isn't it, C3 right there. That's the first, starting on the left, right? First means starting on the left. So starting on the left, you go through, where's the first number 3 marker? Well, the B3, but they're out. B's already got their section. So it's the C3 marker. And what does C get? Well, you go back to their other mark. Where's the, start here. As I go back, you always go to the left, except for the last one will go to the right. Always go to the left, and as you go until you see another of that same letter's marker, which is right there. So it's this 7, 8, 9 goes to C, doesn't it? Because they marked that out. See how C put a marker to the left of 7 and to the right of 9? That means they were marking out section 7, 8, 9 as a section they thought was a fair section. So we give them their marked out section. Finally, we've only got last go right. So on the last, there's only letter left is D. Where's D's last marker here? Go right. That goes to D. Last one we go right? All right. So what was their question? Item 10. Item 10 was their question. Where's item 10? Well, it's right here, and it's left over, isn't it? It's a leftover item that was not in anybody's allotment. We good? Like you can, even if you missed it today, can you get it on the exam week after next? All right. No questions? I'm going to move along. Good. Okay, yeah. So what we're doing in this chapter, right? So chapter 3 was dividing cakes and land and inheritances. Chapter 4 is dividing up representation, right? It's all like Congress, how do different groups get represented fairly. So here we have these different states with their different populations, and basically the idea is the more your population, the more representation you deserve on the board. 33, it's set right there, 33 seats. Okay, so there's 33 seats on some Congress that's going to represent all these states? Well, basically, the states with more population should get more representation on the Congress. So, how do we do that fairly? That's the whole chapter. And really, the problem all comes down to the decimals, doesn't it? What we do for rounding. The whole chapter is how do you round the decimals? And you might think, what do you mean? Just 0.5 is up, 0.4 is down. But that won't always work. I'll show you what I mean. So let's go through. So again, real quick, we had the standard divisor. The standard divisor is, what is it? It's the total, I'm going to put this on your 3x5 card, total number of people over the number of seats on the Congress or whatever it is. So in this case, total number of people, 990,000. It's all in thousands, but I'll just use 990 over 33 seats. So we divide that, we got 30, right? So the standard divisor was 30. And then what do we do with that standard divisor? We take each state's standard quota. Quota is like, what you get, what you should get fairly. Standard quota is their population divided by the standard divisors, their population. So I'll do that. I'm going to do it down here. So the quota for each of these states is going to be, for this one, let me bring these down. It's going to be 138 over 30, because 30 is the standard divisor. This one's going to be 186 over 30. This one's going to be 264 over 30. This one's going to be 402 over 30. So you just divide each of them by the standard. We take their population, divide by the divisor. That's why it's called the divisor. You divide by it. Okay, so what do we get? So 138 divided by 30. I get 4.6. I'm going to need a little more room. So I get 4.6. 186 divided by 30. 6.2. And 264 divided by 30. 8.8. And 402 divided by 30, and we got 13.4. Okay, now that's what they fairly, if all is perfectly fair, that's the number of seats they deserve. Right? Like State D deserves 13.4 of the 13 seats to represent their population fairly, but you can't give them part of a person, right? You can't give them 0.4 of a congressman or congresswoman. You can't do that. They're either going to have 13 or they're going to have 14. You're either going to underrepresent them or overrepresent them. You've got to do one or the other. So how do we do it? Well, so there's going to be different ways of doing it. Hamilton's method, which is what we're doing right now, Hamilton. This is the first one. I'm going to give you 4 methods. We're going to do Hamilton and Jefferson and Adam and Webster. Sounds like a history lesson, doesn't it? It's because this is what really happened in history, in American history, when they were first doing the Congress. All right, so Hamilton, I wrote Hamilton. Hamilton, what's his method? He basically said, look, round all down. And in this chapter, you got to remember, when they say round down, they don't mean round off. That's a different thing. So rounding off is what you're used to. That's like 0.5 goes up, 0.4 goes down. And Webster will pick up on that. Webster's method will be rounding off. But the other methods, Jefferson, Adams, and Hamilton, they'll all say either round up or down. And when they say that, they mean no matter what your decimal is. So round down means even 0.8 here. Even 8.8 is going to go down to 8. So round down means down. And is it Adams or Webster? One of the other, Adams or Jefferson, I think Adams, will say round up. And he means up, like even 2.1 would go up to 3. Up means up, down means down, off is what we're used to. Okay, so round them all down. So first, round this down to 4, round this down to 6, round this down to 8, round this down to 13. How many, if we just give them those amounts, how many total seats are there? If you add them up, what would be the total? Total number of seats, 21, 30, that'd be 31. If you just I just added those up. And it equaled 31. Now we have 33 seats on the Congress altogether, so we have 2 more seats. What are you going to do with those extras? Give extra seats to highest decimals, which makes sense, doesn't it? I think who's this? Hamilton. Hamilton's method. This makes a lot of sense. You just go, all right, we got 31 total, rounded everybody down, got 31 total seats. That means we got 2 extra to give away. Who gets them? Well, the highest decimals, 0.8 and 0.6. So I don't mean the overall highest number, just decimal, right? 0.8 decimal, because he already got his 8, right? He's already got his 8. It's just a question of whether we're going to give him another one or not. You with me? So we're just looking at decimals now. I'm not looking at the whole numbers. We're done with the whole numbers. We gave them their whole numbers. Now it's just about which decimals get an extra. So the 0.8 and the 0.6 are the 2 highest decimals. They're higher than 0.2 or 0.4. So they get the 2 extra seats. So he'll go up to 9 and he'll go up to 5. The other ones stay as they were. And that'll be 33 seats and we're done. And everybody's happy. Well, not quite. That's what we're going to talk about. Not everybody's happy with that plan. Hamilton's plan never actually was used because it's got a problem. I'll show you. But it sure looks good at first, doesn't it? It's like, yeah, that's great. What's the problem? Chapter's over, right? Just round them down. Highest decimals get them. Isn't that fair? Doesn't that seem fair? Well, you might think so. But here's what happened. So that's, everybody got that down? That's Hamilton's. I'm going to flash off that, and we'll come back to it. Here's what happened with, this is literally history. 1882, they were trying to use Hamilton's method. And what they had is they had total number in the House of Reps at that time. They had 299 people. And Alabama, one of the states at that time, had 8 reps for its population. Okay, you track me, you're getting the idea. So this is when the United States was growing back in the 1800s, right? And we were expanding west, and more and more people were coming into the United States, and it was growing. And the House of Representatives was only 299. What isn't it, like 435 or something now? Is that what it is? Yeah. So it's a lot more. It's grown over time. Anyway, so as more states were joining the Union, right? They would join, and we would give them representation on the Congress, and then the size of that House of Reps would grow and all that kind of stuff. And the states were kind of vying for their rights. They all wanted representation on the Congress because that's what the group that decided everything for the nation. Okay. Well, as that was happening in 1882, so Alabama already had 8 representatives. They were using Hamilton's method. Well, they were about to use Hamilton's method. And here's what happened. They decided to increase to 300. They decided just to add a member to Congress and say, hey, look, we're at 299. Let's just go to a nice even 300. So that means, and then they did the recalculation. So they'd already calculated for 299, however many states were in the Union at that time, and all the states got their different amounts, and Alabama got 8 under the 299 calculation. Then they said, hey, let's just throw one more on there, make it 300, and we'll redo the calculation. They were going to use Hamilton's method, what we just did. They rounded them all down and give them back to the highest decimals and all that. And when they redid the calculation for the 300, that's 1 extra member on Congress, right? So I would think, I assume you would think, that some state's going to get an extra one. Some state that had some amount before is going to get 1 extra representative now. They'll be happy, right? Well, here's what happened. When they went up to 300 and redid the calculation using Hamilton's method, not just one state got an extra, but Texas and Illinois both got 1 extra seat. No, not a set. That's tennis. I'm going to go watch tennis today. We've got 1 extra seat on the House of Reps. 1 extra seat. Well, great. 2 states got extra seats. Even better. Well, if 2 states got extra seats, and we only increased the number of seats by 1, what does that mean happened to some other state? They lost 1, and that was Alabama. They went down to 7, and they flipped out. They literally flipped out. Lawsuits and everything, and Hamilton's method was chucked. Yeah, under the calculation of Hamilton's method, when they redid it, the way it works is they were at the Congress meeting, you know, and some congressmen or women proposed, let's go up to 300, and they told the math people to go calculate it and come back to them. You know, they didn't vote it yet officially. They wanted to see what the numbers would be before they did it. So when the math people came back at the next meeting, they presented the findings. They said, if we do Hamilton's method and recalculate it all for 300, here's what you're all going to get. And they said Texas and Illinois are both gaining 1 seat. And they were happy about that. And Alabama is going down. Meaning, see how Alabama would feel. Alabama's population hasn't changed. None of the state's populations. All the populations are what they were when you calculated 290. They're saying, so wait a minute. With 299 reps in Congress, because of our population, we get 8. And then you go more reps, and we get less? How'd that happen? And they felt cheated. They felt like it was a bogus system. And so Hamilton's method can actually do that. So this is a problem. This is called the Alabama paradox. This is kind of like what we've done before, with the voting and that kind of stuff. Same kind of thing. We're trying to use math to help real life situations, but there's problems sometimes with the numbers. This is called the Alabama paradox, and it's a problem that Hamilton's method has. It's a problem for Hamilton's method. So because of that problem, actually Hamilton's method was never voted into law. They were just kind of using it as a, hey, what will happen if we use this method? And they weren't happy. At least Alabama wasn't. And they threw a big enough stink to make it get kicked out. So instead of that method, who's next? Jefferson, I think? Yeah, Jefferson. That's Thomas Jefferson from history, the wonderful. Okay, so here's question number 4 in the homework. And this, by the way, this is the whole section. This is the whole chapter. All we're going to do is do Hamilton's method, Jefferson, Adams, Webster. That's it. And then there's a few paradoxes, like a few weird things that can happen. This is the simplest of all the chapters. So, all right, here's what goes on. Let's do the thing. And so we have 140 seats. They're changing the numbers here. 140 seats on some Congress. Here's the populations for the various states. Let's do Jefferson's method. Maybe I should write out first. Yeah, let me write it here, and then we'll go to a new page and do it. Jefferson's method. Here's what Jefferson thought. He said, all right, find a new divisor lower than the standard divisor. Jefferson thought this. Jefferson thought the problem is you're giving some states an extra seat because their decimal's big enough, and some of them aren't. You know what I mean? Come back over here with Hamilton, right? See how some, like 4.6 got an extra seat up to 5. And so did 8.8. But 13.4 did not. So Jefferson, you know what the problem is you're rounding some people up, right? 4.6 rounded up, 8.8 rounded up, and you're rounding some people down. 13.4 rounded down, 6.2 rounded up. That's why it's unfair. So he thought. I don't agree in the end. I don't think Jefferson's method is actually even as good as Hamilton's. But that's what he thought. And you'll see as we play it out. So Jefferson's first thought was it's unfair because Hamilton's method is unfair because in the end you're rounding some up and you're rounding some down. So Jefferson thought we need a new method where we can just round everybody up or everybody down. Which one is his? Down. So Jefferson thought we need a way we'll round everybody down. So find a new divisor that's lower than the standard divisor, then round every state down. And remember, when he says down, he means down. Even if you have 7.999, you're going down to 7. Right? Down means down. Decimals will be rounded down. But he wants them all to go the same direction. So it's more fair, so he thought. We will see. So round them all down. So, okay. So that turns out to be a little bit of a pain. Let me show you what we have to do. So it's question number 4 again. So question number 4. So first off, what you've got to do is you've got to pick, well, these are lower quotas. So what I'm going to do is I'm going to take each of these. Oh, I got to find my standard divisor. That's it. I'm sorry, I'm stumbling around here. Remember, so let's find the standard divisor. Remember how we find the standard divisor? It's the total population over the number of seats. You guys have a calculator? Total population is 7 million. Over, what's the number of seats? 140, right? It's going to be something ugly probably. 123, over 140. I'm getting, oh, 50,000, that's not bad. Nice clean 50,000. So that's the standard. Everybody with me? That's the standard divisor. That's normally what we divide all the numbers by. That's why it's called the divisor. But here we're going to change it. And this is going to be the same for Jefferson, Adams, and Webster's. You're not going to use the standard divisor. You're going to use, what did he say? If you look back here, he said a lower standard divisor. You're going to use a divisor, a new divisor that's lower than the standard. So, well, how much lower? Yeah, that's the trick. Who knows? You kind of guess around and it's kind of a pain. How about 49,000? I'm just sort of guessing, right? The standard divisor is 50. Let's try. So Jefferson, with Jefferson's method, you use a lower. So how about 49,000? That's a little bit lower. Now, maybe that's not low enough. Maybe we should go down to 48,000 or 40,000, but it's usually close. So we'll try 49,000. Okay, so here, let me just write it over here. I'm going to use 49,000. Jefferson's method wants you to use something lower. Okay, so now let's go back to normal work now. What do you do for the normal work? Let me get this out of the way. You go by and you divide all the populations by that divisor, right? That's the purpose of a divisor. Let's get this out of here. Okay, so here we go. So state A, I'm going to get what's called the lower quote. I'll explain how I got that. What are you going to do? You're going to take their population, 1,059,000, and divide by the, 49,000. All right. Wait, am I? Okay, so take 1,059,000 divided by 49,000. So it's pretty calculator intensive. Don't want to be doing this without a calculator. I'm getting 21.6. We good? Let's do the next one. Take their population. 2,887,000 over 49,000. Oh, you know what you can do to save time, guys? Just cut all the zeros at the end, right? Just skip these 3 zeros and these 3 zeros. It's the same number. Just go 2,887 over 49. Save a little bit of time. So I get 58.9. Next one, I'm going to go just 902 over 49, right? Just take the 902 over the 49, cut out the zeros on the top and the bottom so that doesn't change anything. I'm getting 18.4. And then D, I'm just going to take 2152, just cut out the 3 zeros at the back. 2152 over 49, cut out the 3 zeros at the back, top and bottom. And I'm getting 43.9. Good to there? Now, what are we supposed to do? What did Jefferson say to do with those numbers? So he says use lower standard divisor, which we did, and he says round all down, right? This is Jefferson's way. Jefferson, not Jeff, Jefferson's way, right? Lower divisor, round everybody down. Basically, when we get to Adams, he'll say use higher divisor, round everybody out. He'll just go the opposite. And Webster will say round off. We'll get to that. So basically, these are the methods. So Jefferson said lower divisor, round them all down. So I'm going to round all those numbers down now. So 21.6, round it down, 21. 58.9, round it down, 58. 18.4 goes to 18. 43.9 goes to 43. Look at that. We had 2.9s go down, didn't we? But we did it even. We rounded them all down. Now, is that the answer? Well, only if that adds up. See, here's where it gets tricky. What is the total if you add these up? Whoops, I did 2 plus signs there. if you add these up, what do you get? Is it? Yeah, it comes out exactly right. Now, that doesn't always happen. A lot of times what will happen is it'll come out like 139 or 141. And then you've got to go back and you've got to change this 49,000 and try to raise it or lower it to get it to all work out just right. And it gets really tedious sometimes. This one was super clean and nice. It just worked out right away. Does that make sense? That's Jefferson's method. So again, we got it one shot. A lot of times you got to go back here and just keep fiddling with that thing, 3 or 4 passes until you get all the numbers to add up to the right total. Because that's all the seats you have on Congress, 140 seats. You can't have more or less. So you just keep trying to divide and divide and divide until it comes out right. This one came out right the first time. Yeah?
So whenever you get the divisor, you have to go lower?
For Jefferson's method,
yeah.
yes. So so when you get the standard divisor for Jefferson's, you have to lower it. How much do you lower it? You guess. And I just went down to 49,000. But yes, Jefferson's method is use lower divisor and round down. We're about to go, very next problem, right now, we're going to go to Adams. And Adams, that was Adams from history, President Adams, John Quincy Adams, right? Anyway, he's going to say exactly the opposite. He did in history say exactly. He said, no. Rounding down is a bummer. Nobody wants to be rounded down. What we need to do is round them all up. Then they'll be happy. So he said use a higher divisor and round up. Just exactly the opposite of Jefferson. Instead of lower down, he said higher up. So we might use 51,000. Higher than the standard, than the normal standard divisor. He said Adams is going to say use higher and round up. And get that to work out. It's just as difficult, though. All right, so we'll go back. Okay, so Adams. This is number 5, which is Adams' method. All right, after this, we only have one method left. This is basically the chapter. And it's just practice it after that. Okay, so first off, we have to find the standard. We always start by finding the standard divisor. What's the standard divisor? Total population over number of seats, right? Like it always is. Total population, 7,500,000 over, what's the number of seats? 150. We're going to get 50,000 again. Is that what it is? Whoops. Yeah, 50,000. They're just making it come out nice. 50,000. So I got a nice clean 50. That's my standard. That's my standard divisor. So what kind of a divisor am I going to use for Adams' method? I'm going to use one higher. Like 51,000. Now, is 51,000 really going to work? I think so, but I don't remember exactly. It might be 52,000. Might be only 50,500. I don't know, because sometimes it gets real painful. We'll try 51,000. You guys tracking with me? Is this making sense, what I'm saying? So Jefferson's was use a lower standard divisor and round everybody down. Adams says, hey, let's use a higher one and round everybody up. So let's do that. So now we go back and we do each state, and you know what to do at this point, right? Take the population. Actually, let's cut out the zeros again. That saves some time, right? Cut out the zeros. Just use 3280 and just divide by, oh, not 50. It's 51, huh? 51. See, I'm just cutting out 3 zeros at the back for the numerator and the denominator. Save some button pushing. What do we get? 64.3. Let's do the next one. 2480. I'm just cutting out 3 zeros at the back. Got to cut out the same number of zeros top and bottom. So 3 zeros top and bottom. 2480 divided by 51. I'm getting 48.6. And then 1220 over 51. And I'm getting 23.9. And this one, 520, cut out 3 zeros in the back, over 51. I'm getting 10.2. Good to there? Just use your calculator, crank those. Now, what does Adam, so higher, we're using a higher standard divisor, and then what does Adam say to do with these numbers now? Round up. Round them up. So I'm going to round 64, so I'm going to round up. Everybody up. Up means up. So even 0.3 is going to go up to 65, up to 49, up to 24. Even 10.2 is going up to 11. Oh yeah, that's not going to work. The total is not right. So everybody good so far? Everybody see what I did? I just rounded everybody up. Even the really small 0.3 and 0.2 rounded up. Up means up. So Adams is thinking, we just round them all up, it'll all be good. Well, if you add these up now, what you're going to get is you're going to get 149 seats, but you're supposed to give away 150. So that ain't the answer. We got to fix something. We got to redo it with a different divisor. But let's hold on for a minute. Make sure you're all caught up with me before I whip into a new divisor. Is that good? Everybody see the problem? Do you see why I'm saying this isn't the right answer? We did what Adam said, divided them all by 51, got our answers, rounded everybody up, added them up, and it was only 149 seats. We're supposed to give away 150 seats. We have an extra seat. You can't have that. You got to give away the right number. So that means you got to go back and you got to pick a new divisor. Now, you guys dialed in with me? You hear? I'm not doing the Charlie Brown teacher of the 111, right? You with me? Because this is really important. This is what will save you tons of time or steal tons of your life doing these problems. You got to know which way to go. You don't want to waste a bunch of time. When this comes out too low, you need to take this divisor and go lower, actually. Why does too low mean go lower? Because you're dividing by it, right? Think about dividing with me for a second. If I say, hey, I took 100 and I divided by 20 and I got 5. So what if I divided by a lower number like 10? I get a bigger answer. You see, when you divide by lower, you get a bigger answer. We need more seats. 149 is too low. I need more. So you got to divide. This is a divisor. I've got to divide by a lower divisor, don't I? The answer is not higher than this, it's lower. Now, you never go below your standard, though. So it's somewhere between these guys. Like, I'm going to try 50,500, maybe. So everybody see, because if you go the wrong direction, you're really going to waste all kinds of time. Right? It's like playing warmer or colder. You got to know which way you're going. Right? So one more time. So let me write that. So using 51,000, total came out 149, too low. Right? So go lower on your standard divisor. So something like maybe 50,500. Never below original standard. And the standard was 50,000, right? So you're never going to do that. I mean, you're never going to go below the original, right? Adam's method is going to have some divisor higher than the original. The answer will be something higher than 50,000. But it's lower than 51 because this came out too low. Go lower. Dividing by less will make the numbers higher is the deal. All right, so I'm going to try 50,500. It might not work, but I'm going to try. So let's go back. I'm going to try 50,500. Are we ready? So now the problem is this time I'm going to have to use the entire numbers because I don't have 3 zeros at the back. See, this only has 2 zeros at the back. You can't just cut out all those zeros. You can't cut out 3 zeros at the back of 50,500. So just do the entire number. I mean, you could cut out 2 zeros, but I don't know. You might mess up, so I'll just do the whole thing. So you're going to divide each of these populations by the new divisor and hope it works out. And it might not. So I'm getting 64.9. Next one, 2480000 divided by 50,500. And I'm getting 49.1. Next one, so 1220000 divided by 50,500. And I'm getting 24.1 or 2 or whatever, doesn't matter. It's all going up. Third one, 520,000 divided by 50,500. I'm getting 10.3. Okay, now what are we supposed to do with these numbers? They all round up, don't they, for atoms? Round up, so this would be 65, 50, 25, and 11. They all go up? It's too much. Add them up. If you add these up now, you know how I can tell so quick? You just look at the ones digit. I'm just going 505, that's 10, and 1, 11. There's a 1 in the ones place. So, I don't need the rest of the numbers are going to be close. If you just look at the ones digit, you can tell, oh, it's getting, so it's 100, must be 100. I didn't add it up, but I'm confident it's 151. So, it's too much. So, what does that mean? So, if it's too much, it's too high, right? We only have 150 seats, we don't have 151. It's too high, so go higher. You getting the hang of this? Too low, go lower. Too high, go higher. Now, higher than what? Higher than 50,500. But not higher than 51,000. We already tried 51,000, and that didn't work. We needed to go lower. So, how about like 50,800? This is where this gets painful. You see what we're talking about, right? Everybody, you guys tracking with me? You hating atoms now, right? See, these methods, all these three of these methods are kind of painful. Okay, so we've got to go high. We came out too high, so divide by a higher number will bring things down, won't it? Okay, divide by a higher number. How much higher? I don't know. Higher than 50,500, but not higher than 51,000. I already tried 51,000. Need to go lower. So 50,800, maybe. I don't know. Or 50,750. I honestly don't know. I don't remember. Let's go try 50,800. So here we go. I'm going to try 50,800. I hope this does work. I don't want to do this again. Let's see. So, okay. So 3280000 divided by 50,800. So what's that? 3280000 divided by 50,800. I'm getting 64.6. Next one is 2480000 divided by 50,800. I'm getting 48.8. And then the next one, 1220000 divided by 50,800. Divided by 50,800. I'm getting 24.0. I wonder if this is going to work. Okay, and last one, 520 divided by 50,800. I'm getting 10.2. Okay, round up. Round them all up. 65, 49. 24.0 goes to 25. Did I confuse you there? Let me clarify that one. That one was 24.0157, so it does round up to 25. Not down to 20. If you put it 24, you'd have technically rounded it down. There was some decimal after that. This one goes up to 11. Oh, that's right. That's coming out right, isn't it? I just did the ones digit real quick. Right? 1 and 5 is 6, and 9 is 15, and 5 is 20. 0 in the ones digit. So that's got to be 150. If you add them up. So that worked. So that's the answer. There's how many reps each of the states get. It worked. Is this making sense? So Jefferson's method is all about going down. Lower standard divisor, round down. Adams' method, higher standard divisor, round up. Just keep filling with it till it comes out to be the right number of seats. So Jefferson and Adams both thought the problem is we need to round everybody the same way. Like everybody down for Jefferson, everybody up for Adams. Now, last So Webster's method, what do? First off, you find the standard divisor. We always find the standard divisor for all these methods, right? For Adams, you go up. Jefferson, you go down. For Webster, you try using the standard divisor and round off. 0.5 up, 0.4 down. You know, like normal rounding. If that doesn't work, then you know what to do from there. If it's too low, actually go lower. If it's too high, you go higher, etc. The rest is the same. But the point I hope I'm making clear, is with Webster's, you actually try the standard divisor first. Most of the time, it actually works. The standard divisor itself actually works. That's why I like Webster's better as well. A lot of times you don't have to go with the new divisor. The standard one will actually work just fine a lot of times. So is everybody tracking with me there? Do you see the difference? At the last two methods, Jefferson and Adams, I found the standard but didn't use it. Right away picked lower or higher right away and didn't even use the standard. But Webster, you try the standard first off and round off, and it often takes care of everything right there. You don't need to fiddle around. Is that good? Everybody got that down? So if you got that down, let's find the standard. I'll just do it right on the same page here. What's the standard divisor for this problem? Well, you know, total population over number of seats. So what's the total population here? Well, it's the same one as last time, isn't it? 7,500,000 over 150 seats. That's just going to be 50,000 again. Okay, so 50,000 is the standard divisor like it has been for the last two problems. And what am I going to do? Am I going to go higher right away like Adams or lower right away like Jefferson? No, I'm going to try the actual 50,000. For Webster, try the actual standard. See if it works. And I think it will. But the difference with Webster is we're rounding off. 0.5 up, 0.4 down instead of all up or all down. So let's try 50,000. If y'all got that copy down, I'll go to a fresh sheet and we'll try 50,000. Okay. Oh, I need to make that bigger. Okay. So here we go. I'm going to try 50,000 and round off because it's Webster. It's Webster's method. So here we go. So I'm just going to take 3410. I can cut off the last three zeros. Divide by 50. Right? Just save some time here. 3410 divided by 50. Cut off the zero. 68.2. Let's do the next one. 2440 divided by 50. Just cutting off the three zeros at the back for the numerator and the denominator. Get 48.8. Next one. 1220 divided by 50. And I'm getting 24.4. And last one, 430 divided by 50. And I'm getting 8.6. All right, now what am I supposed to do with those numbers? Round off. I'm supposed to round them off. Webster says round them off. So 68.2, where's that going? Down to 68. 48.8, where's that going?
49.
Up to 49, right? If the decimal's 0.5 or more, it goes up. 24.4 goes down to 24. 8.6 goes to 9. Add them up. I think it's right, isn't it?
Yeah.
Yep, comes out 150. Boom, there's the answer. Pretty good method. Never had to adjust the divisor. Just round it off. Now you might wonder, wait a minute, how's that different than Hamilton? Do you wonder that? Like, how's that different? Isn't that what Hamilton did? Didn't Hamilton? Well, no. Hamilton is close though, very close. Hamilton said, round them all down at first and give the highest decimals the extras. Now, you might say, well, isn't that pretty much what we did here? Well, yeah, the outcome would have been exactly the same for this particular problem, but not always. Like with Hamilton's, say what if you had 3.4, 7.8, 2.3, right? And you rounded and did your whole thing, and you had two extra. What if you had two extra seats? For Hamilton, if you had two extra seats, who would get extra? The 0.8, obviously he's the highest decimal, and the 0.4. Hamilton would give him an extra. Webster never would. Webster would say, no, round him down. He's a 0.4. Just go down. See the difference? So there is a little difference between Hamilton and Webster. Hamilton, the first one we did, said, we're not rounding. We're just whichever decimals. If you had two extra seats, the two highest decimals, I don't care what they are. If they're the two highest decimals, whether they're 0.5 above or not, I don't care. Just the two highest decimals get the two extra seats. See the difference? Whereas, Webster says it's just about rounding. Just round. 0.5 gets extra seat. 0.4 does not. So slight difference between the methods. Okay, that is the first section. That's all the